Let's look at correlations here of scatter plots. They come in different shapes and sizes. And ultimately what a correlation is just simply the pattern found in the scattering of the points. So maybe here's one scatter, here's maybe another scatter, here's maybe another like this, and then here is another scatter. This is known as a positive correlation because think of it just like the line itself. That's a positive slope. This falling to the right is of course a negative correlation. When it's a horizontal line, we call that constant. It is a constant correlation. And then when it is nothing that is obvious, we just say that that is no correlation. So as we look to create lines of best fit, our own lines, we want our line to follow the correlation of the points. So when we create these things, we want ours to follow that correlation. Once we decide the kinds of correlation we're receiving, then it becomes our work to determine the actual equation of the line. So let's practice that. There are two things that are required to get a equation of a line. One is the slope and the other is the y-intercept. So let's take a look at line M first and see if we could obtain both of those things. So here it seems that it's crossed down here at -7, so the y-intercept is -7. The next thing I want to do is find another point that I could count slope out to, and it looks like this is the next point that would work. And so if I was to count that, that would be, looks like 5 up and 1 over. So the slope there is 5 over 1, or in other words 5. That means the equation of our line would be 5x minus 7. Let's take a look at the next one, line N. Line N. It looks to cross at the location of 2, positive 2. That would be its intercept. And then I'm going to look for the next time I see it cross clearly into the, it looks like way down here. The other ones look close, but that's looks the best there, which seems to be, or maybe I'll go the other way. I can find one up here as well. That's also good. So that would be down 3, and it looks like over 5. So our slope is -3/5. That means the equation of our line would be y equals -3/5 x plus 2. This is a quick way to obtain the graph's equation from a graph. So now we combine all of those things together. We want to find the equation of a line. The line has not been graphed, but we have 2 points to work from. So the first thing you would do is obtain the point values, which look to be -4 and 4, and -1 and 2. To get the slope, we use the slope formula, which is the change in y, delta y, over the change in x. Be careful with your negative symbol there, so you'd get -2, -1, plus 4. So our final slope would be, looks like, -2/3. And in truth, you could have counted down 2 and over 3 as well. Now notice there is no y-intercept, and it doesn't look like it would cross at a nice location. So what we're going to do, actually I'm gonna do something here that might help us out. I'm going to turn this into a decimal, which would be -0.67. So let's now try to solve this by plugging in the values into our slope-intercept form. I'm going to use, let's say, this point here. So I'm going to put in the 2 our slope is negative 0.67. That's going to multiply by negative 1, and then we add our b value over there. Sorry, that seems to not quite fit over there, but let me keep going. 2 equals, this becomes plus 0.67 plus RB, because the negative times the negative there. And then when that moves over to the other side, we get 1.33 equals our b value. So our final equation would be y equals negative 0.67x plus 1.33. So that's a little tricky. Let me just kind of go back through that again. The first thing we did is track down our 2 points. Then what we did is we calculated our slope, which came out to be this. And I think for scatter plots it's okay to go to a decimal, so I went to a decimal. The next thing we did was to plug in to our equation up here. We plugged in the slope, we plugged in its x value, its y value, and what that helps us to obtain is the intercept. And then the final item is, in truth, right here. This is the equation of our line, our slope and our intercept. You can look back here now. If I was to graph that line, and if I was to graph that line, I think you would see that it would cross at, not at 2, but somewhere between, and we found out that it would cross at 1.33. So all of this comes down to coming up with the equation of what we call the line of best fit. Now the way you do that is to pick the line that goes through, divides the points fairly equally. It would also give a minimal distance to each point. So, and again, I don't have my ruler with the stylus to do this, but something like this. You would want points on the upper side and points on the lower side. And so I'm going to pick this point here at negative 10 and looks like negative 5. I'm going to pick this point here at 1, 2, 3, and 3 is the other point. So my thought is that the line through those 2 points will divide the group equally. It will be close to that. All of the points are kind of close to this correlation here, and so now I calculate what I think is the best fit line for that particular item. So the first thing we're going to do is we're going to calculate our slope, and you know its formula. And so I'm going to do 3 subtract a negative 5, and I'm going to do 3 subtract a negative 10. I get 3 subtract a negative 10. I get 8/13. Now 8/13, let's turn that into a decimal, because again, I think it's just easier when dealing with all these uglier numbers to work with a decimal, and I get 0.62. So we're going to use that as our slope. Now we want to know what the y-intercept is, so we're going to go mx plus b, and we get to pick any point we want. I'm going to pick the 3, 3. I'm going to use this location here, and so I put in my 0.62 times 3 plus b. And when I multiply 0.62 times 3, I get 1.86. And then when I subtract 3 minus 1.86, I get 1.14 equaling b. Now let's go back and see if that kind of looks like that. It does look like it kind of crosses at 1.14. And so now we are indeed ready for our equation of our line of best fit. Would be y equals 0.62x plus 1.14. That would be the line, our our best estimate of the line of best fit. I use this point and I use this point to obtain my slope, and then I was able to calculate my B value and obtain my best fit line.